record the session. Yes, now we can start. All right. So this is section 2.5. And again, it's about zeros of polynomial functions, right? Polynomial functions. Right. So so we have this theorem, the rational zero theorem. So let me just remind you the rational zero theorem. So the rational zero theorem, which says the following. So rational zero theorem. So it says the following. So we have f of x, a polynomial. So here we have x to the power n. In front of x to the power n, there is a subscript n. That's the number in front of x to the power n. Plus etc. So we have powers of x, and at the end, of course, you have a constant. So just a number by itself, a subscript 0. All right, and so we said the possible rational zeros. So when I say zeros, it's the same thing as the roots, and that's the same thing as the x-intercept, right? So x-intercept. So the possible rational zeros are given by, so you take the factors of the constant, the a0. So here's my constant, the number by itself, a subscript 0. So factors of a0 over the factors of the leading coefficient, the a subscript n. So so here's my leading coefficient. That's the number in front of the coefficient in front of x to the power n, right? So we said this is the list, so that we give us the list of possible solutions of f of x equal to 0. So now I'm going to show you how to. So now the goal is, so I'm going to show you how to use this theorem to factor f of x completely. All right. So use the theorem to factor f of x completely. Right. Okay, so let's have an example. So let's say f of x. Okay, so let's say f of x be equal to, let's say 3x cubed plus 8x squared minus 15x plus 4. All right, and so the questions are the following. So first, so this is similar to the homework. Okay, so this is similar to the homework number 6, problem 5 and 6. All right, so first we're gonna list, so let's say 1, list all possible rational roots okay, of f of x. 2, factor f of x completely. Okay. 3, find the x-intercepts. Find the x-intercepts and their multiplicities. Okay. And then let's say, okay, so, and then 4, find the y-intercept. Okay. 5, determine the behavior at infinity of f of x. Of f of x, and then finally graph the function f of x. So 6, graph f of x. All right, so let's start with number 1. So 1, you have to list all possible rational roots of f of x. So so number 1. So the list of possible rational zeros. So we said, so using our rational zeros theorem, so we have to take the factors of the constant. So here, of course, the constant would be the number by itself, so which is 4 here. So here's my constant, right? So this is my a subscript 0, right? So the factors of 4 over the factors of the leading coefficient. So leading coefficient, again, guys, that's the number in front of the highest power of x. So here is my leading coefficient. It's 3. All right, so it's factors of 4 over factors of 3. So so it's factors of 4 over the factors of 3. All right. So now the question is, what are the factors of 4? So 4 divisible by 1. So that's plus or minus 1, divisible by 2, and it's divisible by itself. Now, what about 3? Well, it's just divisible by 1 and by itself. All right. So then the answer, so the list would be, so we have to divide each of the factors of 4 by each of the factors of 3. So here in my list, we're going to have first, so we're going to divide 1 here by 1 and then by 3. So that's 1 divided by 1, of course, that's 1. And then 1 divided by 3, that's 1/3. Now the same thing for 2. Here 2. Divide by 1, it's 2, and divide by 3, it's 2/3. Now 4 divided by, so we see here 4 divided by 1, and then divide by 3. So it's 4 over 1, and then 4 over 3. So this is the list of possible rational zeros of my polynomial, right? Now, so we did this last week, right? Wednesday last week. Now, I'm gonna use this list to factor f of x completely. So how I'm gonna use this to factor f of x? Well, so so here number 2. So I want to factor f of x. So there are 2 steps. Factor f of x. So in the first step, you have to try the numbers in the list until you find a solution of f of x equal to 0. So step one, try numbers in the list to find one solution, all right, of f of x equal to 0, all right? Now, once you find one solution, okay, so you don't have to try all the numbers, right? Just find one solution of f of x equal to 0, and then in the second step, you have to divide. So step 2, so divide f of x by x minus the solution you got in the step 1. The solution we got in the step 1. All right. Once you divide f of x by x minus the solution we got in the first step, then we can, and then you have to factor. So the next step 3, you factor the quotient. Okay, and so f of x. So, so let's try to do this. So first step, we said we have to try the numbers in the list to find the solution of f of x equal to 0. So 1. So here's my list. All right, so this is my list, of course. So this is my list here, right? So first number in the list, of course, you have plus, positive, and -1, right? So I'm gonna try, I'm gonna see if positive or -1 are solutions of f of x equal to 0. All right, so let's say you try +1. So first number in the list is +1. So let's try see if +1 is a solution. So to see if +1 is a solution, all you have to do, guys, is to plug +1 in the function f and see if you get 0. If you get 0, then that will be a solution, right? So you have to, so f of x, let me write it again for you, f of x. F of x, we said it's, where is it? It's the 3x cubed, you know, etc. So f of x, my f of x is 3x cubed, right, plus 8x squared minus 15x plus 4. So let's try +1, see if +1 is solution. So that's 3 times 1 cubed times 1 squared, 15 times 1 plus 4. So here, +1, f of +1 would be 3 plus 8 minus 15 plus 4. And that will be 11 minus 15, -4 plus 4, and that's 0. Right, so I got 0. So that means that 1 is a solution. It's a root. So I got 0. So then, and so, so here conclusion, +1 is a 0 or a root, right, of f of x. If you don't get 0, guys, then you have to try the next number, right? So you stop once, if you get 0, then you stop, and then you can move to the next step, all right? So I guess in the test or in the final, I mean, you won't have to try all the numbers in the list to get the solution, right? Probably the first or the second number would be a solution, right? So once you get the solution, now I can move to the next step. The step 2 is to divide. So as you can see here, step 2, divide f of x by x minus that solution. So I'm going to divide now in the second step. So this is step number 2. So I'm going to divide f of x by x minus the solution we got in the first step. So it's x minus 1, right? Because 1 was the solution, right? X minus 1. That's my solution here in step 1. All right. So divide f of x by x minus 1. So we know how to divide polynomials. So this is x minus c, right? So my c is actually, so c is equal, so it's x minus 1. So c, remember guys, it should be the opposite, right? Minus 1, x minus 1. So c is positive 1, right? That's my solution, right? That's my c. Now, okay, so now let's divide. So here's my, I'm going to put c here. So that's positive 1. Here, I'm going to put f of x. So we have x cubed, we have x squared, x constant. So it's 3x cubed, 8x squared minus 15x plus 4, right? So we always bring down the first number here, which is 3 times 1. That's positive 3. 8 plus 3, that's 11. 11 times 1, it's 11. Minus 15 plus 11, that's negative 4. Negative 4 times positive 1, it's negative 4. 4 plus negative 4, it's 0, right? So remember, guys, we have to multiply the last row by our c, right? So, and of course, I got 0 as the remainder because I knew that positive 1 would be a solution, and because positive 1 is solution, so then the remainder should be 0. So this is here my remainder, and of course here this is my quotient, right? And so this is, of course, so for the quotient, guys, this should be 1 degree less than f of x, so 1 degree less here. So if you have x cubed, then here should be x squared, then x, and then constant. All right, so then my quotient is 3x squared plus 11x minus 4. All right, so we are done with this step 2. So we divided our f of x by x minus 1. So the answer, so the final answer here in the step 2, guys, should be like, remember we have our f of x should be equal to our divisor. We divided by x minus 1, right? This is my divisor. We divided f of x by x minus 1 times the quotient, right? So times the 3x squared plus 11x minus 4, right? And of course here this should be plus, you know, here plus the remainder, but the remainder is just 0, so it's just plus 0, right? So it's plus 0. So yeah, so that's my f of x. Now I divide my f of x by x minus 1. So now what would be the next step? So in the step 3, we have to factor the quotient, and so f of x. So now I can try to factor the quotient. So step 3. So where's my quotient? Well, here's my quotient, right? This is here. This is the quotient, right? So so we need to factor the quotient in the step 3. And so step 3, factor the quotient, which is actually a quadratic function, right? It's 3x squared plus 11x minus 4. Okay. So how do you factor? Well, this is a quadratic function, right? And you want to factor a quadratic function. I mean, there are different ways actually to factor quadratic functions. But I would say the easiest way would be to just solve f of x equal to 0. So here we can just solve the quotient equal to 0. All right. So we can solve the quotient equal to 0. So that's the 3x squared plus 11x minus 4 equal to 0. It's a quadratic equation, so we can use a quadratic formula. And so my solutions, so minus b is 11 plus or minus square root of b squared. 11 squared, that's 121, minus 4 times a times c. Right, over 2 times a. So the x, it's minus 11 plus or minus square root of, so 121 minus, that would be a plus. This is a plus. 4 times 3, that's 12. 12 times 4, that's 48. And 121 plus 48, that would be 169. So this is 169, right? This is 169. Square root of 169 is actually 13, right? So it's over, so don't forget to divide here by 6. So your x is minus 11 plus or minus 13 over 6. All right, and so of course then your x is negative 11 minus 13 over 6. That's negative 24 over 6. So that's negative 4. Or x is negative 11 plus 13 over 6. So that's 2 over 6. You reduce the fraction, right? Here you divide by 2, divide by 2. So that's 1/3. Right? So I got negative 4 and 1/3. So what I'm going to do with this negative 4 and 1/3. So this is my negative 4 here, 1/3. Those are the solutions of my quotient equal to 0. So what I'm going to do with them? Well, so then your quotient, here's the answer. So again, guys, the goal here is, we said we have to factor our quotient, right? We have to factor this 3x squared plus 11x minus 4. So all you have to do, guys, is so this is my quotient, which is 3x squared. We said minus 11x plus 11x minus 4, plus 11x minus 4. So how do we factor this using the solutions? Well, so the factorization here is going to be of the form. So here you're going to have x minus the first solution, because it's a quadratic equation, right? It's a square, so we expect 2 solutions. So it's x minus first solution times x minus the second solution. All right. And one more thing, you need to put the number in front of x squared here in front of the factorization. So here you always bring down this the number in front of x squared. You have to put it here in the front. Okay. So it's 3 times x minus first solution times x minus the second solution. So it's going to be 3 times x minus the first solution. So x minus, my first solution is negative 4. So it's minus negative 4 times x minus second solution is 1/3. Right? So this is actually, this is a factorization of my quotient, right? Is there any question, guys? So all you have to do is solve your quotient equal to 0, and then for the factorization, it's always of the form x minus, let's say your quotient is a quadratic function, right? So it's always of the form x minus the first solution times x minus second solution, right? And just don't forget to put this number in front of x squared in the front here, right? Because you see, guys, the thing is, when you multiply this x here by this x, you get x squared, not 3x squared, right? So we need the 3 here in the front to get 3x squared. All right, so I got my quotient, and so now we are done. So now I can answer question number 2. So conclusion, find answer. Remember, guys, in this question number 2, we have to factor f of x completely, right? That was the question here, right? I know it's a long question, but so in this number 2, we have to factor f of x completely, right? So so remember here, my f of x was x minus 1 times the quotient, right? So f of x, conclusion. So my f of x, we said f of x is x minus 1 times the quotient times the 3x squared plus 11x minus 4. But then we factored the quotient, right? So we said x minus 1 times, and then we said this quotient here, this one here, that will be this 3 times, so times 3 times the x minus negative 4 times x minus 1/3. Okay, and I mean, if you move the 3 to the front, okay, let's just move the 3 to the front. So f of x would be 3 times x minus 1 times x minus negative 4. That would be x plus 4 times x minus 1/3. All right, so then this would be a final answer. This is the complete factorization of f of x. So this is the complete factorization of f of x. All right, I just moved this 3 here to the front. All right, and then here I said x minus negative 4, that would be plus 4, right? Minus minus, that would be plus. So this is the complete factorization of f of x. Any question, guys?
Yeah,
I mean,
because
it's a long it's a long step. I mean, it's a long question, but
yeah,
I
yeah, no,
mean,
like I
uh-huh.
understand how you got that. Like I know the x minus 1, the x plus 4, and the x minus 1/3. That's supposed to be the three solutions because in the
Yes.
very beginning, yeah. But then wouldn't it be x minus 4? Because our solution was like
No,
negative 4, like the
and so
what?
yeah, the thing is, yeah, just because it's supposed to be x minus the solution, but we got negative 4 as a solution, right? So it's x minus negative 4, but then the minus
Okay.
minus would be a plus.
Yeah, yeah.
Hmm.
I just thought for some reason it just was supposed to still be negative 4.
Yeah, yeah. So, but I mean, the idea again. Okay, let me just come back to the general idea here. We want to factor this f of x completely, right? So we said in the first step, you have to try the solutions, the possible solutions in your list, right? Once you get one solution, I got here, well, here I was lucky, well, kind of lucky. So the first number I tried was positive 1,
Yeah, it was
and it
positive
turns out to
1.
be it turns out to be a solution, right? Because I got 0. So once I got my solution, then I can move the next step, and then I have to divide my function by x minus that solution, right? So x minus 1,
Mm-hmm.
because I got 1, right? I divided f of x. I got the quotient. All right, so my f of x is now x minus 1 times the quotient. But the thing is, because you want to factor completely f of x, right? The thing is, you want to factor this, right? You need to still need to factor this, this 3, sorry, this 3x
The
squared
quotient.
plus, yeah, the quotient. And so that's what I did in this this step 3. I want to factor this 3x squared plus 11x minus 4. Well, and I mean, this is a quadratic function, so I mean, there are different ways to factor it, but I would say the easiest way would just say to use the the quadratic formula, because once you have the solutions using the quadratic formula, then the factorization would be like of the form like x minus the first solution you get times x minus the second solution, right?
Yeah.
Right, and so then you get the factorization of the quotient, and once you get the factorization of the quotient, then you're gonna have the factorization of the whole thing, right? Because that's the missing thing. All right, so that's the complete factorization. So next question number. So this is number 2. Number 3. Find the x-intercept and their multiplicities, right? So now I got the factorization, the complete factorization of f of x, and now in number 3, question number 3, I have to. So this is now number 3. I want to find x-intercepts of f of x and their multiplicities, right? So once you have the complete factorization of f of x, so the x-intercepts again is just solutions of f of x equal to 0, right? So here all we have to do is to solve f of x equal to 0. But I mean, if you use the number 2, you know that f of x, it's 3 times x minus 1 times x plus 4 times x minus 1/3, right? Equal to 0. So here we have a product. So this is why the factorization, the complete factorization, is very useful, because once you completely factor the f of x, so now we have a product, okay, just a product which is equal to 0. Then you can say either the first, so then either the first factor is 0, so either x minus 1 is 0, or the x plus 4 is 0, or the x minus 1/3 is 0, right? So then x minus 1 is 0, then x is positive 1, x plus 4 is 0, then x is negative 4, x minus 1/3 is 0, then x is 1/3. So you see why this complete factorization is very useful, because you get like a product. Okay, so then your function f is now it's just a product of factors, and you have a product of factors equal to 0, then one of the factors is 0. Okay, so yeah, we are done actually. So the final answer here, x-intercept, the x-intercepts are, so first I got x equal to 1, right? So that's 1, 0, and is of multiplicity. So what's the power of x minus 1? X minus 1 is power 1, right? This is power 1 here. So 1, 0 is of multiplicity 1.
They're all of the multiplicity of 1, right?
They all, yeah, absolutely, yeah, exactly. So this is power 1. Oops, this is also power 1. So all of them are of multiplicity 1. So this is negative 4, 0 is of multiplicity 1. 1, and 1/3 is also sorry, 1/3 0, because this is supposed to be x-intercept, so we need to add the I mean the x-intercept should be in the points notation, so that's why I need the comma 0. Sorry. So -1, sorry, positive 1/3 0 is of this T1. So yeah, all of them are of this T1. All right, so that answered number 3. Now what's number 4? Okay, number 4 was, and then we have to find the y-intercept. Right, this is my x-intercept and their multiplicities. So now number 4. So you see, guys, why we had to factor f of x completely, because once you factor f of x completely, then you can find the x-intercepts, right? Number 4, find the y-intercept. The y-intercept, again, is just f of 0. So you have to evaluate f of 0 and evaluate f of 0. So that would be, you know, your f of x was 3 times, so 0 cubed plus 8 times 0 squared. So you plug 0 in the function f, right? And then minus 15 times 0, and then plus 4. So then f of 0 is 4. And so the answer, y-intercept, is 0, 4, right? What else? Now, next, we have to determine the behavior of f of x at infinity. I mean, we did this, I guess, 2 weeks ago or last Monday. So for the behavior at infinity, so you have, so your f of x is 3x cubed plus 8x squared minus 15x plus 4. So the degree is equal to 3 and is odd. And the leading coefficient, the number in front of x cubed, the highest power of x, is 3, and it's positive. So the leading coefficient is 3, and so it's positive. Right? So then if you take your table, when the degree is odd and leading coefficient is positive, then the behavior at infinity would be at negative infinity, your graph is gonna be right here, and when x goes to positive infinity, then here's your graph, right? And then final question, graph f of x. Okay, so number 6, the graph. All right, so I'm gonna need to plot. So first, of course, here, this is our graph at positive and negative infinity. We have to plot the zeros or the x-intercepts. So plot the x-intercepts and the y-intercept. So what x-intercept we got? Yes.
Please, I want to take a picture a little bit. Yeah.
Sure. Here?
Yeah.
Okay, sure. So I think the x-intercept, we got x equal to 1.
It. Thank you.
You're welcome. We got x equal to 1, right? So let me plot here. So we got x equal to 1. We got, and we got in a negative 4, negative 2, negative 3, negative 4, and we got 1/3, right? So let's see, this is 1/3. So this is 1/3 here. All right, this is 1, and here it's negative 4, right? Negative 4, 1/3, and positive 1. That's my x-intercept. And y-intercept, we got 0, 4. So my 2, 3, 4. So here are my x-intercepts, -4, 1/3, and +1. And here's my y-intercept, it's 0, 4. Now, so now I can graph my f of x. So we start from the bottom here, and then you're gonna join the -4. Now at -4, again, guys, there are two possible behaviors of the graph at -4. Either you're gonna cross the x-axis, or you turn around, you touch the x-axis at -4, and then you turn around. But because the multiplicity of -4 is 1, that's odd. So then you cross the x-axis. You arrive at 4. Next is 1/3, and at 1/3 multiplicity is 1. That's odd. So I'm gonna cross the x-axis. And then next point is +1, and I'm gonna cross the x-axis at +1 because the multiplicity is odd, and then you are done. So that's my f of x. All right. So don't forget to check the multiplicity of your x-intercept, right? If it's odd, then you cross the x-axis. If it's even, you touch the x-axis and you turn around. Right? Any question, guys? Okay, so that's just one example. We spent like almost like 50 minutes in one example. But anyway, yeah, that's that's like a standard problem in a test or in final. All right, so this is like a standard problem. Okay, so here's an exercise, a similar problem.
Wait,
Yes, please.
sorry, I just didn't remember when you cross the graph. Why is that again?
Yeah, that's because when the multiplicity is odd,
Okay.
yeah, like in -4, we said all of them are of the multiplicity of all our x-intercepts is 1, right?
Yeah.
So yeah, if
Yeah. So that's why
multiplicity
it
is
just keeps
odd,
on going to like 4.
yeah, yeah,
Yeah.
that's when the
Okay.
multiplicity is odd. Yeah. All right.
Yeah. Okay.
So here's an. All right. So here's an exercise. Well, similar exercise, right? So, so let's say f of x is -3x³ minus 7x squared plus 22x plus 8. All right, this is plus 22x plus 8. So this is -3, of course. So -3x³ minus 7x squared plus 22x plus 8. So what you have to do, guys, so this is our polynomial. Let's just do the first list all possible rational solutions or zeros. 2, factor f of x completely. And then let's say 3, find the x-intercept. Find the x-intercepts and their multiplicities. Right. Because we don't have much time, guys. So just let's do this 3 questions, all right? For the y-intercept, the behavior at infinity, and the graph, I mean, we had already like similar problems, right? Where we have to find the graph, the function f, and find the behavior at infinity. Yeah, so we have, let's say, 10 minutes to think about this exercise, guys, all right? I'm sorry if there's any noise in the background.
Wait, so then for the factor of -3, what do we do? Like, I'm guessing it would just be -1 and -3 as the factors?
Yes, but you have you always take the positive and negative, the plus and minus, right? Plus and minus one, plus and minus three.
Even when
Yeah. It doesn't matter if it's positive or negative.
Alright,
Mm-hmm.
alright.
My advice, guys, when you check the numbers in the list, if they are solutions of f of x equal to 0, so I would start with the whole numbers, right? Uh, so check first the whole numbers if they are solutions of f of x equal to 0, right? And then if all the whole numbers in the list they don't work, then you can check the other numbers, the fractions. So first start trying checking if the whole numbers are solutions of f of x equal to 0.
Hey, Professor, you said like
Yes.
when we factor it completely, you said to test out all the whole numbers first before we go to the fractions.
Yeah, I mean, yes. Try, yeah. Yeah,
I
try
think
the whole
that's
numbers first
no,
because
I think it tested most of
actually
the whole numbers. I don't think the
no,
whole numbers work.
no, they gonna work. So positive, yeah. If you try positive and negative one, obviously they. I mean, yeah, the positive and the negative one, they are not solutions, right? But
Mm.
if you try positive two would be a solution actually.
Really? Okay, I guess I fucked up the math then.
Yeah. So any guess for the x-intercepts? What will be the x-intercepts of f of x?
I'm not even at that step yet. I gotta give it like a
Okay.
few more minutes.
All right.
All right, well, I think I have the x-intercepts.
Mm-hmm.
They are, the x-intercepts are -4, -1/3, and 2.
Yep. Yeah. Very
This is
good. Very
feasible.
good. Yep. Very good. Yeah. All right. So, okay. So let's start with number one. Possible rational zeros. So, so for number one. So the list of all possible rational zeros. So we have the factors of the constant, which is, so in this case, that will be the positive 8. That's our constant, a subscript 0, over the factors of -3, and that will be our leading coefficient. So the factors of 8 over the factors of -3. So factors of 8 over factors of -3. So that will be factors of 8. So as I said, it doesn't really matter if it's positive or negative. So in the factors, anyway, you have to take the plus or minus. Okay, so factors of 8, of course, divisible by 1, 8 divisible by 1, divisible by 2, divisible by, not divisible by 3, obviously, right? Divisible by 4, and not by 5, not by 6, and then by itself. Now, same for -3. Again, doesn't matter if it's a negative or positive 3. We're gonna have the plus or minus 1. 3 obviously is not divisible by 2, but it's of course divisible by itself, right? So then you have to divide each of the factors of the top by the factors in the bottom. So then 1 divided by 1, plus or minus 1. 1 divided by 3, that's 1/3. 2 divided by 1, it's 2. By 3, it's 2/3. 4 by 1, 4. By 3, 4 over 3. And then obviously 8 by 1, that's 8. Plus or minus 8. And then plus or minus 8 over 3. Right? So this is the list of all possible rational zeros. Now, 2, we have to factor f of x completely. Right? So step 1, we said we have to check. Check the solutions, the list, the numbers in the list. So I'm going to check if the numbers, check the numbers in the list and see if there are solutions of f of x equal to 0. All right, so let's check first positive 1. So f of x, let me write down here, f of x. F of x is, we said it's the negative 3x cubed. So it's negative 3x cubed minus 7x squared plus 22x plus 8. So first number in the list. So let's try plus or minus 1. So let's try positive 1. So f of positive 1, that's negative 3 minus 7 plus 22 plus 8. So that will be 20, which is not 0. So positive 1 is not a solution. Now, if you try negative 1, negative 3 times negative 1 cubed, that will be positive. Negative times negative, that will be positive. So that's positive 3. Minus 7 times negative 1 squared. So that's negative minus 7. Minus 22 plus 8. And that will be equal to, so negative 4, negative 26, negative 18, which is of course not 0, right? So neither one, positive or negative 1, are solutions, right? So as I said, my advice, guys, because I mean the whole numbers are easier to try than the fractions, right? So my advice is to try the next whole numbers. So we have positive or negative 2, right? So let's try positive 2, right? So let's plug positive 2 in the function f. So f of positive 2. So that'll be negative 3 times 2 cubed minus 7 times 2 squared plus 22 times 2 plus 8. So that will be equal to negative. So 2 cubed, that's 8. 8 times negative 3, that's negative 24. Minus 2 squared, that's 4 times 7. That's negative minus 28. 22 times 2, that's 24. 44. That's 44 and plus 8. So that will be equal to, so negative 24 minus negative 28, that's negative 52 plus 44, that's negative 8 plus 8, and that's actually equal to 0. Right, so positive 2 is actually a solution. So x equal to positive 2 is a solution of f of x equal to 0. So I got now my solution is the solution of f of x equal to 0. So now I can move to the next step where you have to divide your f of x by x minus the solution you got, right? So this is step number 2. So step 2. So I'm gonna divide f of x by x minus the solution, our solution, right? Positive 2, so x minus 2. Okay, so so what will be my c then? Well, it's x minus 2, so my c would be positive 2. So c is, of course, that's my solution. It's positive 2. So here's positive 2. My f of x. So we have negative 3x cubed minus 7x squared. X's, we have 22x. And constant, we have 8 plus 8. So positive 8. Right? Bring it down to 3. Negative 3 times the positive 2, that's negative 6. Negative 7 plus negative 6, that's negative 13. Negative 13 times 2, that's negative 26. 22 plus negative 26, that's negative 4. Negative 4 times 2, that's negative 8. And as expected, plus 8, positive 8 plus negative 8, that will be 0. So as expected, we got 0 as the remainder, right? So this is here, we got 0 as expected because positive 2 is a solution. So the remainder must be 0, right? And here's my quotient. So it's 1 degree less. All right. So then my quotient would be negative 3x squared minus negative 13x minus 4. And so my f of x would be my divisor. I divided by x minus 2, right? Times my quotient. So times the negative 3x squared minus 13x minus 4. All right, so we're almost done. Again, guys, the goal here is to factor f of x completely, right? I got my first factor, x minus 2, but then I have to factor the quotient, right? So that's our next step. So this is step number 3. I have to factor the quotient. So factor the quotient. So factor the quotient. And how do you factor the quotient? It's a quadratic function. So we can use the quadratic formula and find solutions. So we have to solve the quotient equal to 0. So we're gonna solve negative 3x squared minus 13x minus 4 equal to 0. As I said, if you know how to factor a quadratic function without using the quadratic formula, then that's good, right? So, but if you don't know how to factor in general quadratic functions, then you can use the quadratic formula, right? So you can solve the quadratic equation. So that's minus negative 3 plus or minus square root of, so negative 13 square minus 4 times a times c, which is negative 4, right, over 2 times negative 3. So your x would be positive 3 plus or minus. So 13, negative 13 squared, that's 169. 169, and here will be minus, here's a plus, and there is this minus here, so it's going to be negative. So it's 169. So here it's square root of 169 minus 4 times 3, that's 12. 12 times 4, that's 48. Over negative 6, right? So my x would be positive 3 plus or minus. So 169 minus 48, that will be 121. Square root of 121, it's 11. So this is plus or minus 11 over negative 6. So x is 3 plus 11 over negative 6, or positive 3 minus 11 over negative 6. So 3 plus 11, that will be 14 over 6. Sorry, here it's minus. I said here it should be 13, right? 13, it's not 3, right? It's minus b. Sorry, here it should be minus 3. This is minus 3 here. 13, sorry. So it's minus negative 13 here, right? So that's plus 13, plus 13. So this is plus 13 actually, right? So 13 plus 11, that will be 24. Sorry here, so it's 24. This is 24 over 6. That will be equal to 4. And this is 13 minus 11. That's 2 over negative 6. You reduce the fraction, so that's actually negative 1/3. Right? And so then your quotient. So I got these two solutions. I got this positive 4 and negative 1/3. So then my quotient, which is negative 3x squared minus 13x minus 4. So that will be equal to, so how do we factor this quotient using the solutions I got here, the 4 negative 1/3? So again, it should be of the form x minus the first solution you get here times the x minus the second solution. And don't forget to put in the front the coefficient of x squared. So here you have negative 3, so you have to put negative 3 here in the front. So negative 3 times here, of course. So then your quotient would be, it's negative 3 times x minus, so the solution I got here first, I got 4, so x minus 4 times x minus the negative 1/3. Okay, so this is a factorization of the quotient. So then I can, so now I have the complete factorization of f of x. So then here's my f of x. Remember, f of x, we said it's x minus 2 times the quotient times the negative 3x squared minus 13x minus 4, right? That's our f of x. But now, so f of x would be equal to x minus 2, right, times, so this quadratic function, so turns out to be actually times, so negative 3 times x minus 4 times the x minus negative 1/3. All right. So that's my quotient, right? And so in other words, this is if you move the negative 3 to the front, so f of x would be actually negative 3 times the x minus 2 times the x minus 4 times the x minus negative 1/3. That would be x plus 1/3. Right? So this is the complete factorization of f of x. Any question, guys? Nope. All right.
Wait, hold on. I did.
Yes.
Wouldn't that be x plus 4, not x minus 4?
Let me see. Probably I
Yeah, because
messed
you
up
have,
here.
because when it's 13 plus 11
yeah. Sorry. It's
yeah,
my
it
mistake.
should be negative 4.
Yeah. You're completely, yeah. Actually, I forgot. You're absolutely right, because I forgot here, this is minus 6, so it's minus 6. I forgot my minus, so it's negative 4, minus 4 here. Absolutely, you're right. So here it's actually minus negative 4. And you're absolutely right. So this is then minus negative 4. And so it's plus 4. Absolutely. Thank you. So yes. Yeah, so that's my f of x. And then once you get f of x, the complete factorization of f of x, now we can, so we can find our x-intercepts and their multiplicities. All right, so that's f of x, negative 3 times x minus 2 times this x plus 4 times the x plus 1/3 equal to 0. Okay, so that's what we have to do, right? Whenever you want to find the x-intercept, you have to solve f of x equals to 0. But now my f of x is it's just a product of factors. So then either the first factor is 0, or the second factor is 0, or of course the third factor is 0. So x minus 2 is 0, then x is 2, positive 2, then x is negative 4, and then x is negative 1/3. So to answer the question, so all the x-intercepts, so answer, so the x-intercepts are, so we have positive 2, we have negative 4, we have negative 1/3, and all of them, like our previous example, all of them are of multiplicity 1, right? Because the power of the factor of all the factors here are 1. So and all of them are of multiplicity 1. Multiplicity 1, right? That's the power here of our factors. All of them have power 1. All right, guys. Any question?
I do sort of have like a question though, because like let's
Yes.
say like because I just wanted to take a back step, like instead of using the quadratic formula, I find it just much faster just to factorize it, just like
You
the
split the negative 13, like sum of. Yeah, I mean you can
yeah
do that, but it's just because some people that are not
yeah no
familiar. Yeah, I
it's
mean it's up to you. Sure. I mean
yeah
it's up to you.
it's fine, but like when I factorize that, what would be the step from there? Like how would I figure out the exact like you know
I mean,
how we got like -4 and -1/3?
yeah, because once you factor, you get your, let's say, x plus 4 times your x plus 1/3. So once you get your factorization, then you're done, right? Because that will be our complete factorization of f of x. So if you know how to factor the quadratic function without using the quadratic formula, then it's fine. I mean,
All right.
well, is that what you mean, right?
Uh, sort of, but like I kind of don't want to take up time because I know like this shit does require like a lot of time. So I would rather you just continue the
I
question.
think, yeah. I mean, the easiest, I would say the easiest thing is just use it because everyone knows how to apply. Well, I mean, yeah. I mean, I guess everyone knows how to apply the quadratic formula, and that's all you need actually to factor your quadratic function. But I mean, if you know another way to do it, then yeah. If you are familiar with another way to do the factorization, and there are different ways actually to factor quadratic function, right? But just because because everyone knows how to apply the quadratic formula, then I think that would be like the easiest thing for everybody.
Okay.
But anyway, yes. Is there any other question, guys?
And
Yes. All right. Okay. So it's 11:35, so we have like 15 minutes, and 15 minutes to start a new section. Probably that's not. Can probably give you one more. Probably it's a good idea to give you one more exercise rather than start a new section. Yes, okay, let's do that because 15 minutes is not enough, I guess. Yeah, I will start section 2.6, I guess, next Wednesday. So here's another exercise. I mean, similar problem, all right? So exercise number 2, I guess. So exercise number 2. Okay, so let's take another function f. Okay, so let's say f of x is now, oh yeah, this is even better. Okay, so let's say f of x is x fourth minus 6x squared minus 8x plus 24. All right, so here's the question, guys. One, of course, first you list all possible rational zeros. Rational zeros. Then 2, and then 2 factor f of x. This is a little bit different from the previous example, the previous exercise, because here this is, you see here, this is a polynomial of degree 4, right? It's not of degree 3, right? So factor, so 2 factor f of x completely. So just a remark here, guys. So this is different from the previous exercise because your quotient, once you find the solution, then your quotient is gonna be of degree 3, not degree 2, right? So here, so the quotient is gonna be is of degree 3, right? And you want to factor the quotient, right? So what you have to do, guys, is you have to you have to find the possible rational roots for the quotient and check, find possible rational zeros of the quotient, right? If you don't know how to factor the quotient, then you can always try the possible rational zeros. I think in the homework, all the polynomials are of degree 3, right? Okay, so the problem number 5 and the problem number 6 in the homework both are of degree 3. So it's gonna be just similar to the exercise, the previous exercise, right? Okay, guys, I'm sorry. I mean, we have just like 5 minutes. So I'm gonna go over the exercise very quickly. I mean, this is kind of similar to the previous one, but your function f here, it's of a degree 4, right? So, well, first, you want to list all possible rational zeros. So the list is gonna be, well, the constant is 24, and the leading coefficient here, it's 1, right? It's 1 times x4, so it's factors. So here we're gonna have factors of 24 over the factors of positive 1, right? So then the list would be factors of 24. So we have, of course, 1, 2, 24 is divisible by 3, of course. So it's plus or minus 3, divisible by 4, divisible by 6. What else? And divisible by 8, right? Divisible by 12, right? And then, of course, is divisible by itself, right? Over, so factors of 1, it's just 1. So this is just plus or minus 1. All right, so then the list would be, of course, would be just, so we have to divide by 1. So then the list would be plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. All right. Now, what's really important is the question number 2. So you want to factor f of x completely, right? So for 2, so we said first we have to, try the numbers in the list. So if you try 1, f of 1, for example, f of positive 1, then that will be, if you plug 1 in the function f, so where's the function f? Yeah, here. So we're going to have 1 to the power 4 minus 6 times 1 squared minus 8 times 1 plus 1, 4, plus 24. So that's 1 minus 6 minus 8 plus 24. So that's actually minus or negative 13 plus 24. That's plus 11. So it's not 0, right? And if you try negative 1, you're going to have negative 1 to the power 4. That's positive 1 minus 6 times 1 square, negative 1 square, that's positive 1, so it's minus 6, plus 8 plus 24. So that will be minus negative 5 plus 8, that's plus 3, plus 24, it's plus 27, it's not 0. Now, if you try the next number, or the whole number, which is positive 2, so then f of positive 2 would be, so 2/4 minus 6 times 2 squared minus 8 times 2 plus 24. So 2/4, that's 4 times 4, that's 16, minus 4 times 6, that's 24, minus 16 plus 24, and that's obviously equal to 0. So yes, so then 2 is the solution, right? So 2 is a solution, right? And is a solution. So in the next step, we are supposed to divide our polynomial by x minus 2. Step 2. So we're supposed to divide f of x by x minus 2. So then just be careful here with the division. So your c is positive 2. Your f of x is gonna be x4, so 1x4, 6 minus 6x squared, So here you see, guys, after x fourth, you are supposed to have x cubed. So here we're supposed to have x cubed, but there's no x cubed, so it's going to be 0, 0, x squared, minus 6, and then x we have minus 8, and then constant we have plus 24. Anyway, so when we divide, so this is 1 times 2, this is 2 times 2, this is 4, negative 2 times the 2, that's negative 4, negative 12 times 2, that's negative 24, and as expected we got 0. But anyway, my point here, guys, and I'm gonna finish with this, so my point is here the quotient is gonna be, so it's 1 degree less, so x fourth over here it's x cubed, x squared, x, and this is constant, right? So the quotient is actually 1x cubed plus 2x squared minus 2x minus 12, right? And the next step, I'm supposed to factor this, right? How do we factor this quotient? Factor the quotient. So what we can do, guys, because this is not a quadratic function, right? It's x cubed, so it's not quadratic function, right? So I cannot really use the quadratic equation. So what we can do here to factor this quotient is, well, repeat the same process. So we can try to find the list of possible rational zeros. So here we have to repeat the step 1. Step 1, yes.
Why don't we partial factor it then?
Or you can try to partial, but the thing is here, partial factoring, I don't think is gonna work because, let me see. Oh yes, it does work actually. Or you can, yes, absolutely. You can repeat the step 1 or try partial factoring. Yes, absolutely, you're right. You can partial factor. Yes, absolutely. Partial factoring here. But I'm saying in case of the partial factoring doesn't work, well, here it works. Because yeah, x squared would be, you can pull out the x squared is common factor here, and you're gonna have x plus 2, and here you have 2. You can well, no, actually the partial factoring doesn't work here because you're gonna have if you pull out the x squared, you're gonna have like x squared, x plus 2, right? And here, let's say minus 2 is a common factor. So minus 2 times x plus 6. So it's not, you see, you won't have a common factor. So if the partial factoring works, that's good. So you can just use partial factoring. But if, like in this case, it doesn't work, so what you have to do is to repeat the step 1, find the list of, possible zeros, and try the numbers in the list and divide, etc., etc. Right? Anyway, guys, I'm gonna, sorry, I went over time as usual. So I'm gonna stop here, right? And on Wednesday, I will start the section 2.6, all right? Thank you, everyone. Thank you for your time. See you on Wednesday.
Hi, Professor, have a good day.
You too, Francesco, thank you. Take care. Take care, everyone.
Sir, thank you.
Thank you so much.